Okay, hello, welcome back. That last video I decided to put up even though it was dark, but that's why I stopped it. I thought it was dark. We got some light now. So this is the second video. Also, that last video was very theoretical. It was definitions and things that perhaps you already know. This video is about this. We're going to finish angles. We're going to convert from radians to degrees, and then two formulas, arc length and area. And then we're going to go, this is actually the second section, unit circle, and we'll define sine and cosine and talk about Pythagorean Theorem. And then that'll be it for this video. And then there'll be a third one finishing section 3.2 coming later. So here we go. Yeah, we talked about radians and degrees. Degrees being, these are units of measure. Degrees are totally arbitrary. 0 degrees is 0 radians. And then 360 degrees is 2 pi. So then I'm just dividing. You can divide that in half. 180 is pi. Yeah, see, you have to write the degrees. 90 is pi over 2. 45 degrees then be pi over 4. 30, by the way, is 90 divided by 3. It's pi over 2 divided by 3 is pi over 6. Oops, 30. That's 30. And so these are going to become second nature to you. 45 degrees is pi over 4. And all we're doing is taking a circle and we're just cutting it up into pieces. Pi over 6, 30 degrees. And so, you know, now, how do you convert between radians and degrees? Conversion. Between radians and degrees. Well, what we're doing, we said 30 degrees is pi over 6. So given 30 degrees, how did we get the pi over 6? You take from degree to radians, you just multiply it, radian, by pi over 180. It's like degree measure times pi over 180. So it's like 30 times pi over 180. 30 over 180, that's the 6. Pi over 6. You know, so what's 45 degrees times pi over 180? Well, that's the 4. 45 times 4 is 180. Pi over 4. So what's like, I don't know, you know, 220 degrees times pi over 180. Well, I'd mess with these. 22 over 18 is 11 over 9. Sounds like 11 pi over 9. You know, we're just converting. You multiply by pi times 180. And then so we go backwards and we convert from radians to degrees. Degrees to radians times pi over 180. And radians to degrees, then, we would do it backwards. You would divide by 180 over pi. Divide by 180 over pi. Or you multiply by 180 over pi. So what we're doing here is we're taking, say, let's see, pi over 3 times 180 over pi. There we go. The pi's go 60 degrees. Yeah, so degrees to radians, radians to degrees. Please, in calculus, put your calculators in radians. By the way, there are mistakes coming up in calculus when you have it in degrees and you'll have the wrong answer, or you'll have it in radians. Make sure you know what mode your calculator is in. Radians or degrees, most of the time, because it's real. This is real, this is arbitrary. We're working in radians. So there's that. Two formulas, arc of a circle, length of an arc of circle. Here's a circle, you know, there's a radius here, there's R, and here's a angle, and what we want to say is how big is that? How, you know, what's the measurement of that? And in order to do that, you take it, this arc length is S equals R times theta. Simple as that. So, for example, if you have a 12-inch radius and you have a radius and you have an angle of pi over 4, 45, you may as well make it 45 degrees. This comes second nature to you. You know, how long is the arc length? Well, what we're talking here is there's a circle, there's 45 degrees, this is 12 inches, and here's pi over 4. So the arc length is just 12 inches times times pi over 4, which is, let's see, 3 pi. So this is about 3 pi. It's about 9 units right there. That's about 9. 3 pi is 3.14, so it's a little more than 9, maybe 10. And then the other formula is to find the area of a sector. Area of a sector. Sector is defined as, let's do the same problem. There's 45 degrees, oops, pi over 4, not really. And this is 12 inches, and so we want to find the area, which means you have to have a dimension twice. You need an r squared. And all this formula is area is a half theta r squared. And that's it, that's the area. So for example, in this problem, it'd be a half times pi over 4 times 12 squared. Times 144, 72, 36, 18 pi. 18 pi, let's see, that's about 3, 18, 36, 15. Yeah, so that's, you know, 54, 56-ish square inches. And we go. So that's pretty much it for this, this particular section. We do have to talk a little bit about coterminal. And yeah, one more thing, coterminal angles. And really, it's going to become reference angles. And this is important in terms of doing trig. And what we're saying here is, if you have an angle, well, say you have an angle, we'll call it theta. In the first quadrant, well then, that's redundant. But here in the second quadrant, what we want to do is always make an angle with the x-axis. So suppose you're here, and there's theta. The way you analyze trig is not through that angle, but rather through this one, called theta prime. And that's called a reference angle. In the second quadrant, quadrant 2, the reference angle is, let's see, that's 180 degrees minus theta. Or pi minus theta, if you're in radians. Third quadrant, we'll just keep going. Third quadrant, you have an angle down here. That's theta. Here's the terminal side, which is moving. A reference angle always makes the closest angle to the x-axis. So a reference angle, closest angle to the x-axis. Let me go with examples. This means that this is theta right here minus 180 degrees. Or 2 pi, or pi, minus pi. And so that's a reference angle. This is the angle right here. That's the thing you're going to be talking about when you do trigonometry. And I'm sorry, I'm going to the other board, quadrant 4, and I'll even explain this a little further. There's a circle. Here's an angle in quadrant 4. That means this angle is like this. Angles go clockwise. Unless they're negative, then they'll go counterclockwise. So this is the angle, and we're calling it theta. And a reference angle, theta prime, is always the angle made to the closest x-axis. Angle to x-axis. These two quadrants, it was the negative x-axis. Here it's down to that x-axis. This time, we're talking right here. Theta prime. I'm going to need some colored chalk tomorrow, huh? That's theta prime. So in the third quadrant, the reference angle is all the way 360 minus theta. Or 2 pi minus theta. Depending if you're... and actually, that's what you're looking at, you folks. Okay, so that's all that. That's pretty much it for the section on angles. And I'm just going to introduce sine, cosine, unit circle. Because this is how we start trig. I'm going to do 2 definitions. That's it. And then we'll bring it up in the next video. The unit circle is a circle, vertex origin, and radius 1. And all of trigonometry can be derived based on this unit circle. There we go. It's on the coordinate plane. That's the vertex. Here is the initial ray of an angle. Here's an angle. Go up that way. We'll call it theta. This unit circle has a coordinate x, y. I'm going to define 2 things that, again, all of trig is based on definitions and derivations. This is a definition. Definition. Sine, it's S-I-N-E, of theta equals y. Cosine of theta equals x. That's it. That's it. Notice this r is 1, by the way, because it's the unit circle. If r was not 1, it'd be y over r and x over r. We'll get to that, I promise. So there's the 2 definitions, and then keep in mind, note, x squared plus y squared equals r squared. R is 1, so here's the first identity. When trig does this all the time, identities. Sine squared plus cosine squared equals 1. Boom. That's essentially the Pythagorean Theorem. That's the first identity. All of trig can be derived from here. We'll help you with that in the next video. See you later.